online science teacher. I'm here to help you be a Sci fanatic. Our topic for today is about the different types of compounds, whether ionic or covalent, based on their properties such as melting point, hardness, polarity, and electrical and thermal conductivity. Let's have a quick recall of our past lesson. Here, I want you to name the elements involved in the compound and the type of element, whether it is metal or non-metal. So number 1 is already done. This will serve as your guide. So carbon dioxide is composed of 2 elements, carbon and hydrogen. And on the third column, carbon is a non-metal and hydrogen is a non-metal also. So that's the instruction for this recall. You can pause the video while doing this simple task. So these are the answers for our recall. For sodium chloride, we have sodium and chlorine, which is a metal and a non-metal. For glucose, we have carbon, hydrogen, and oxygen. They are all non-metals. For benzoic acid, we have carbon, hydrogen, and oxygen. Also, they are all non-metals. These are the key questions for you to ponder upon finishing this video lesson. How will you identify and describe ionic and covalent compounds based on their chemical formula and chemical name? What are the different physical properties of ionic and covalent compounds? And lastly, how will you distinguish ionic from covalent compounds based on their physical properties? Compounds play a big part in our everyday life. Like for example, you can find these compounds present in our food, air, cleaning chemicals, and literally in every object that you can see or touch. Compounds are made up of elements that are chemically bonded by electrostatic forces. Compounds can be classified as ionic or covalent. An ionic compound is formed when a metal or a cation transfers its valence electrons to a non-metal. The covalent compounds is formed when non-metals share their valence electrons with another non-metal. Ionic and covalent compounds can be identified and described through their chemical formula and name by observing the types of elements involved in a compound. In chemistry, the chemical formula is a symbolic expression signifying the number of atoms present in a molecular substance. We determine the type of atom by referring to its chemical symbol. The number of atoms is determined by the subscript attached to the symbol. On the other hand, chemical name shows the name of each element involved in a compound. For example, carbon dioxide. The chemical formula is CO2. This means that this is an example of covalent compounds, since the elements involved are non-metals, namely 1 carbon atom and 2 oxygen atoms. Moreover, sodium chloride with a chemical formula of NaCl is an example of ionic compound, since the elements involved in a compound are sodium, which is a metal, and chlorine, which is a non-metal. Anna is preparing lunch for her family. While gathering all the ingredients for her recipe, she's a bit confused between 2 identical spoons. One spoon contains salt or NaCl, and the other contains sugar. Both substances are white crystals. and solid in room temperature. Without tasting the sample compounds, how will she know if the compound is ionic, which is the salt, or covalent, which is the sugar? Let's go to the different properties of compounds. At normal atmospheric pressure and temperature, covalent compounds may exist in solid, liquid, or gas, while ionic compounds exist only as crystalline solids. Ionic compounds generally have higher melting and boiling points, while covalent compounds have lower melting and boiling points. Ionic compounds are hard and brittle, while covalent compounds are soft and flexible. I want you to take note of those properties. Let's have additional properties of compounds. Ionic compounds have high polarity, while covalent compounds have low polarity. Ionic compounds are usually soluble in water, while covalent compounds tend to be less soluble in water. Ionic compounds tend to be less flammable than covalent compounds. Ionic compounds conduct heat and electricity compared to covalent compounds. And these are the properties of compounds, so take note of these properties. Now let's go to some activities. Put on your thinking cap. Again, you can pause the video while answering these activities. For activity 1, the brand new me, I want you to study the different illustrations below and answer the guide questions. You can write your answers in a separate sheet of paper. These are the answers for activity 1, the brand new me. Question number 1.
What are the types of elements involved in the formation of NaCl and H2O?
Sodium chloride is composed of sodium, which is a metal, and chlorine, which is a non-metal. Water is composed of hydrogen, which is non-metal, and oxygen, a non-metal.
Number 2. How do sodium chloride and water form?
NaCl is formed by ionic bond, which involves transferring of electrons, and water is formed by covalent bond, which it gains electrons.
Number 3. What leads to the transfer or sharing of valence electrons between elements in a compound?
Atoms with relatively similar electronegativities share electrons between them and are connected by covalent bonds. Atoms with large differences in electronegativity transfer electrons to form ions.
For question number 4, what type of compound is sodium chloride and water?
Sodium chloride is an ionic compound, while water is an example of covalent compound.
Number 5, how will you identify and describe ionic and covalent compounds based on how they are formed?
Ionic compounds are formed by transferring of electrons from metals to non-metals, while covalent compounds are formed by sharing of electrons between non-metals. For activity 2, Power Up, I want you to study the 4 experimental setups below, testing the electrical conductivity of sugar and salt. For setup A, you have salt granules. For setup B, you have the sugar granules. For setup C, salt dissolved in water. And setup D, sugar dissolved in water. I want you to record your observations on a separate sheet of paper, answering the table below. These are the answers for activity 2, Power Up. So we have here 4 setups. Setup A contains only the salt granules. Setup B, sugar granules. Setup C, salt dissolved in water. And setup D, sugar dissolved in water. You are going to identify the physical state of the sample materials, if they are solid or liquid. And also, you will identify if they can conduct electricity. Okay, let's start with sample A or setup A. For salt granules, it is in solid state and it does not conduct electricity. For setup B, it is also in solid state and it doesn't conduct electricity. For setup C, it is in liquid form and it conducts electricity. For setup D, it is in liquid state and it does not conduct electricity. Take note that the only sample, salt dissolved in water, conducts electricity. These are the answers for activity 2, Power Up. Question number 1.
Which among the sample materials conduct electricity when dissolved in water?
Only the sample salt dissolved in water conduct electricity.
Number 2. Explain why salt can conduct electricity when dissolved in water but not in its solid state.
Because the sodium and the chlorine atoms are free to move around the water as positively and negatively charged particles.
Number 3. Why does sugar cannot conduct electricity in both solid and in a solution?
Because they do not contain ions in significant numbers.
Number 4. What type of compounds are sugar and salt?
Sugar is an example of covalent compound, while salt is ionic compound.
Lastly, what type of compound can conduct electricity?
Only ionic compounds can conduct electricity. For activity 3, naming ionic and covalent profile. I want you to study and analyze the description below to identify the given samples. Complete the table number 2 to show the chemical name and the classification of samples. Let's read the different properties of the different samples. For sample A, it is an odorless, colorless gas at room temperature, also known as dry ice in solid state. Sample letter B, an odorless, transparent liquid at room temperature. Letter C, a sweet, white, odorless powder solid at room temperature. Sample D, a salty, white, crystalline solid at room temperature. Sample E, liquid at room temperature with a strong odor. It is the key ingredient in rubbing alcohol. Lastly, a white or off-white crystalline powder. It is usually used in flavor enhancer in cooking. And these are the answers for activity 3. Check out your answers if you got them all correct. I hope we achieved our objectives for the day. Thanks for watching. I hope you had a fantastic day.